The first thing we'll do is learn the basic welding technique. Once you learn the basics, then we'll turn our attention to the trickier applications. There are 5 major variables in the nitrogen welding process. We'll abbreviate them TAPAS: temperature, airflow, pressure, angle, and speed. The temperature will be around 450 to 900 degrees Fahrenheit, depending on the type of plastic. The airflow for thin plastics will range from 7 to 15 liters per minute. Pressure refers to the downward pressure on the welding rod. You should press down on the rod with about a ½ pound of downward pressure as you make your pass to make sure the rod and the plastic fuse together. Angle refers to the angle between the torch and the plastic. It should generally be about 45 degrees with the airflow pointed toward the area where the rod and bumper meet. Finally, the speed should be about 4 to 6 inches per minute. It's common for people to go too fast and not get sufficient fusion. The temperature is set with a hot air welding temperature control dial. It has settings ranging from 1 to 8. 8 is the maximum temperature, and it's not recommended to run at this level for long. Set it at about 6 initially and adjust it up or down as needed. See the literature that came with your kit for recommended temperature settings depending on the type of plastic. Once you switch the flow over to nitrogen, adjust the fine flow control to between 7 and 15 liters per minute on the flow gauge. Lower flow is used on very thin plastics. The thicker the plastic, the greater the flow you will need. Don't keep the flow below 10 for very long. It may burn out your heating element. Make sure the airflow is about 15 when the welder is turned to the air side so the element is protected. The angle of the torch to the work is also important. Generally, you want the angle to be about 45 degrees so you're blowing hot nitrogen on both the bumper and the rod. However, if the bumper is very thin, you may want to focus most of the heat on the rod and not the bumper. Or, if the bumper is thicker than the rod, you may need to focus more heat on the bumper. It will take some practice before you get the feel of where to direct the heat. Pressure is the downward pressure of the welding rod onto the surface. You need to apply about ½ pound of pressure down on the rod so that the two plastics fuse together as you make your pass. Speed is the last variable. You need to control your speed to about 4 to 6 inches per minute. The natural tendency is to go faster than this. You'll need to slow yourself down to make sure the plastics have time to melt and fuse together. Let's take a look at a basic weld keeping TAPAS in mind. After the plastic's been cleaned and roughed up, we start by blowing the hot nitrogen gas on the bumper. Notice that the plastic starts to turn glossy as the surface melts. Lower the rod down and preheat the end of it at the same time. You'll need to heat for about 10 seconds. Touch the rod to the bumper. When it sticks, apply pressure and fold the rod forward slightly so that the first quarter inch of welding rod sticks to the surface. Keep the torch at a 45-degree angle and focus the heat where the rod and bumper come together. You want to pre-melt the top surface of the bumper in front of the rod and also pre-melt the bottom surface of the rod before it comes down to meet the bumper. Once you get it going, you should have a small puddle of melted plastic in front of the rod. Some melted plastic should extrude out the sides as well, leaving a furrow of plastic along the edges of the rod. Keep a steady downward pressure on the rod. The rod should naturally fall onto the bumper as everything gets to the right temperature. Again, you want to control your speed to about 4 to 6 inches per minute. Continue welding until you want to end the weld bead. At that point, fold the rod down to the bumper, focus the heat on the top of the rod until the rod turns clear. Then you can nip it off using the torch's nozzle. This demonstrates the proper way to do a basic weld. Now, let's look at a few common errors. First, don't try to go backwards. You want to move the rod toward the torch as you make your pass. Second, don't lay it down and try to melt it from the top. You can't get any good fusion between the rod and the bumper this way. Third, don't go too slow to the point that the rod has no structure. If you see the rod getting totally clear like this, it won't have any strength and you can't get any downward pressure on the bumper. The bottom surface of the rod should be melted, but the top shouldn't, so that it can support your downward pressure as you make your pass. We recommend that you practice on the back side of a scrap bumper so you get the feel of doing this basic welding process. The coordination of these 5 variables takes practice to get the feel of. The more you practice, the better you'll get.
Before we move on, let's take a look at using the TAPAS method using the 1/8" diameter round rod. This is one of our most popular profiles. It's great for tucking into tight areas and to weld cracks that are not quite straight.
After cleaning the plastic and grinding the V-groove with a die grinder, preheat the plastic and the end of the rod to begin the weld. Here you can see that the angle of the torch is a little flatter with more heat focused on the rod. This rod is thicker than the ribbon, so it will need to get a little more heat to get it melted. Once the plastics get to the proper temperature, touch the rod down and start welding. Just as with the ribbon, keep the heat focused where the rod meets the bumper, pre-melting the rod and the bumper and fusing them together with downward pressure as you make your pass. You won't be able to see a puddle in front of the rod as you did with the ribbon though. We also have a wide ribbon for maximum strength on backside reinforcements. Here, use the same method as on the narrow ribbon. Preheat the bumper and the end of the rod. Touch the rod down, get it folded over, and control your speed so the rod and bumper are both pre-melted before the pressure exerted by the rod fuses them together. With the wide ribbon, you will need to move the hot nitrogen flow in oval motion to melt the ribbon all the way across. Note the puddle of plastic in front of the ribbon as you make your pass. Note that if the ribbon has tapered edges like this, you probably won't get a furrow of plastic on each side of the rod as you did with the narrow ribbon. Get some practice doing welds with the TAPAS method on a scrap bumper before you graduate to repairing an actual tear in the bumper. When you're ready, go to the next section of the DVD and we'll cover how to repair a basic tear to the edge of the bumper.